Hello and welcome to Walking Talking Mocks with Budehaven Science. This video will look at energy changes during reactions. We will cover the subject knowledge you need to answer this style of question. You will then be given the opportunity to answer an exam style question with an example answer followed from me. Here is the exam question. To answer this 4-mark question, you'll need paper, a pen, a calculator and something to time yourself with. To answer this question, you need to understand the changes in energy in reactions. We look at reactions that take in energy and reactions that give out energy. Reactions that take in energy from their surroundings feel colder at the end of the reaction. These are called endothermic. Reactions that give out energy to their surroundings feel warmer at the end of the reaction. These are called exothermic. A common way of remembering this is to think of exo as exit. The energy exits the reaction, so there is more energy in the immediate surroundings than in the bonds, hence the increase in temperature. Here are some examples of exo and endothermic reactions that you should be aware of. Energy changes in reactions can be compared easily using simple apparatus. You will have done this as a required practical during your lessons. It's important to note that these reactions should be carried out in an insulated cup, such as polystyrene. This is to reduce the effect of the temperature of the surroundings, so the energy change recorded is only representing the breaking and making of bonds. We can think of the change in energy over the course of the reaction in 2 parts. The energy needed to break the bonds of the reactants and the energy released when new bonds are made. I remember this using the phrase bendomex. So breaking bonds requires energy, so it's an endothermic process, and making bonds give out energy, so it's an exothermic process. This means that all reactions have exo and endothermic parts, but whether more energy is taken in or more energy is given out decides if it is endo or exo. This change in energy can also be shown with an energy profile for the reaction. This is used to show the difference in energy between the reactants and the products. It can also show how much activation energy is needed to start off a reaction. Here's a reaction profile for the exothermic reaction. It shows there is less energy in the reactants than the products. This is to be expected because the energy is given out during the reaction. Here is a reaction profile for an endothermic reaction. There is less energy in the reactants than the products as energy has been taken in. It's important that you can label the parts of the profile, so you should be able to identify or draw the reactants, products, activation energy and change in energy. The reactants are always on the left and the products always on the right, but which is higher or lower in energy depends on the type of reaction. The overall change in energy is the difference between the reactants and products. Activation energy is much higher in endothermic than in exothermic reactions, as a lot of energy is needed initially to break the bonds. Finally, we can also compare energy change in a reaction quantitatively. There is an amount of energy needed to make or break bonds which is specific to the type of bond. So for example, a carbon-to-carbon bond would have a different value to a carbon-to-hydrogen bond. Although the same amount of energy is needed to make or break a bond, the overall energy of reactants and products are different, as different bonds are formed. You are not expected to remember these figures. The exam board will give you the bond energies they want you to work with when they set the question. When working with this kind of question, I think it's best to compare reactants and products in the same way as balancing an equation. So let's use this equation as an example. If we take the balanced equation, we can list the bond energies present in the reactants and the products. We need to list how many of each type of bond are on the reactant side. It's important to take notice of the number of moles of reactants and products. We do this using the balanced equation. Because the balanced equation shows that 2 moles of methanol reacts with 3 moles of oxygen, we need to take this into account with our calculations. In order to compare this, we now need to do the same for the product side. This enables us to compare the total for reactants and the total for products. From the workings, you can see that we've totaled the amount of energy needed to break the bonds of the reactants, and we've totaled how much energy was released when the bonds were made on the products. Finally, because the reactants bonds are broken before new bonds can be made, we must minus the products from the reactants. So 5,614 minus 6,932 gives us a total of minus 1,318. When the total is negative, The reaction must be exothermic. This is because it's clear to us that more energy was given out to make bonds than was used when breaking them. Now over to you. You have the opportunity to answer an exam-style question. You should pause the video for 4 minutes to answer this question, and an exam answer will follow from me. You should show your workings for this question, as if you make an error, marks can still be awarded for your workings. Please pause the video now. Here is my answer. Upon reading this question, the first thing I do is divide my page to compare the reactants and the products. I know I need to calculate the products without the carbon to bromine bond to work out the difference between the overall answer of -51 and the answer you get when you take the products from the reactants without the bond. If you're still struggling with this topic, please see your teacher or come to one of our Wednesday revision sessions.